डॉक्टर बाबासाहेब आंबेडकर ओपन युनिव्हर्सिटी.
Namaskar dear students and learner of this course. I am Professor Kamesh Rawal. I welcomes you in the video lecture series of Dr. Babasaheb Ambedkar Open University. We have discussed how the decimal number which we are using in our day-to-day life, right? How we can convert it into the form of binary, right? We know that the machine can understand only a one language, and that is the language of ones and zeros. That is also known as a binary language. Why the machine can understand a machine level language or binary language only? That is because of, our machine is actually made by ICs, right? And in that IC there are several small electronic components are there, and those components we can charge or we can discharge. So based on it, if the component, particular capacitor or transistor, if it is a charge, then we can say yes, it is electron is present, and that will be represented as a 1, right? But suppose if you discharge any electronic component, in that case the cell, the binary cell will be empty, there is no electron is there, right? And in that case we can make an assumption that it is a 0, right? Because there is no capacitor or transistor is not charged, no electron is there. Okay, so the machine can understand only machine level language. It is a language of ones and zeros, right? So that we have discussed. Then we have seen there are several different type of numbering systems are there. We have discussed binary. Obviously it is a numbering system, right? That will be understood by the machine. Second numbering system, that is called a decimal number system. So obviously in our day-to-day life, right, whatever numbers we are writing, that is of a decimal, right? Two more numbering systems are there which we can use in our computer science. That is called octal and hexadecimal. Fine. So in this session basically we will just try to learn what is actually octal numbering system, right? Along with that we will see how can we convert, right, any decimal number into the octal number. We will also learn how, suppose octal number is given to you and you need to convert it into decimal number, then what is the method or procedure that we need to follow. Here we will see, suppose if the octal number is given to you and if you want to convert that particular number into the binary, so what you need to do. And finally we will see the reverse thing of it. Let's suppose the binary number is given to you, and suppose if you need to convert it into the octal number, then what procedure that we need to follow. Fine. So let us start our discussion. As in the last session we have discussed a binary. It is a numbering system, right? So this is basically used in the machine level language, right? Or we can say it's a binary language. Now see, in the this binary language we are using only two symbols, right? So these two symbols are what? They are zeros and 1, right? Similarly in the octal numbering system what we have is we have 8 different symbols, right? And those symbols are, it is 0, 1, 2, 3, 4, 5, 6 and 7. Decimal, that is the numbering system which we are using in our normal life. In that numbering system we are allowed to use 10 different symbols, right? So when we are writing a number, any digit can have either 0 or 1, 2, 3, 4, 5, 6, 7, 8 or 9. Similarly we have the hexadecimal system. Hexadecimal is a numbering system whose base is a 16. So here to represent a single digit we can use a 16 different symbol, and those symbols are 0 to 9, then A, B, C, D, E and F, right? So these are the 4 different type of numbering systems are there. Okay. Now suppose if we have a octal number system, right? So what is actually octal number system? So in the octal number system what we have is we have 8 symbols, right? So you can use 0 to 7, but 8, 9, these symbols are not allowed in the octal number system, right? So what we can say is, because here in the case of octal number system we can use only 8 symbols, right? and due to that reason the base of the octal number system is 8, right. Now suppose here several numbers are given, right. For example, 19 is there, 54 is there, 173 is there, and suppose if you want to convert these numbers into the octal format, right. So what you need to do is you just need to divide this particular number, right, by 8, right, because you just think in the case of the number is given to you, decimal number is given to you, and if you want to convert it into the binary, we have divided that number by 2, right. Why? Because the decimal number is given to you and you want to convert it into the binary, right, and we know that the base of the binary is 2. So we have divided that number by 2 and then we have returned all the remainders, right. The same thing, the same approach you need to apply over here, right. Suppose if any number is given to you that is a decimal number, and if you want to convert it into the octal, what you need to do is you just need to divide that number by 8, right, and every time you just have to note down the remainder. Finally, when the number turns to 0, when the number will be a 0, at that time all the remainders you just need to write it down into the reverse order. Okay. Now let us assume, let's suppose here we have 19, right, and we just want to convert this 19 into the octal number. So what I will do is I will divide this 19 by 8, right. So 8, and we know that 8 2 ja 16. So here 2 will be there, okay, and 8 2 ja 16, right. 8 3 ja, obviously it is 24, but 24 is, it is a bigger than 19. So we will just consider 8 2 ja 16, right. Okay, but what the number is given to you? It is 19, right, not 16. So how many things, what will be the remainder? It will be 3. So you just mention or record 3 here, okay. Then again I will try to divide this 2 by 8. Now we know that we cannot divide 2 by 8, right. What is the reason? Because 2 is already smaller than 8. So here we will divide in this way, 8 zeros are 0, okay, and how many things remain? 2. So that 2 you just write it down here, right. So here the remainder will be what? 2 and 3. You just need to write it down the remainder in this way, okay. You just need to write it down your remainder in this way, and it will make what? 23. So what we can say is here the 19 decimal is equivalent to into the bracket 23, you just write 23 and then you complete the bracket and then you write 8, right. Similarly, let us suppose if this 54 is given to you, okay, and you want to convert it into the octal, right. So here again what you need to do is you just need to divide it by 8, okay. So 8 6 ja 48, okay. Now the number is what? It is 54, right. So 54 minus 48, what you are getting is 6. So 6, right, it is the remainder. Again we will try to divide this 6 by 8 because we need to continue this process unless and until we are not getting 0, right. So here we are trying to divide this 6 by 8, and obviously because 6 is a smaller, so here we will write 0. So 8 zeros are 0, but the number is 6. So obviously how many thing remains? 6. So you just mention 6 remainder here, and then you need to write it down this remainders in this way, right. So obviously here what you are getting is a 66. So what you can say into the bracket 66, right. 66 is the octal number, right, of 54, okay. So here similarly, let us suppose if 173 is there, okay. So what you need to do is you just need to divide this number 173 by 8. So here 8 2 ja 16, so you just mention 2. Now one remainder is there, so you just consider 1 here, right? So here you just understand 1 and then 3. Okay, fine. Now 13, so 8, 8 1 ja 8, 8 2 ja is 16, so 8 1 ja 8, fine. So 8 1 ja 8, but here what thing we need to bring? 13. So 13 minus 8, so how many thing remains? 5, so you just mention 5 here. Okay. Similarly, again I will try to divide this 21 by 8. So we know that 8 2 ja 16. So here a 2 is there, here 8 2 ja 16, so 2 is there, right? Again 8 2 ja 16, but what we need to bring? We need to bring 21. So again the 5 will be a remainder, so you just mention 5 as a remainder, right? Again you just need to divide this 2 by 8, so again you write 8 here, because 2 is a smaller than 8, so we will use 8 zeros are 0 and 2 is the remainder, right? Okay. Now when the number becomes 0, what you need to do is you just have to write down all the remainder into this way. Okay. So that will make what? 255. It is the octal number of the decimal number 173, right? So in the decimal we are writing 173, but let's suppose if you want to represent that number into the octal form, you need to write 255. Okay, fine. So here the examples whatever we have done, that is mentioned here. Okay, fine. Now you just try to understand, let's suppose if we are writing a decimal number, so that will have a 10 symbols, right? So we are just starting from the 0, right, and then we are writing 1, then 2, 3, 4, 5, 6, 7, 8, and here when we are writing 9, all 10 symbol gets completed, and when all the symbols will be used, then we need to switch over to the 2-digit number, right? So we are just switching to 10, then 11, then 12, 13, 14, 15, 16, 17, 18, 19, right? Similarly 20 and 21. Suppose the same number if we are writing in the octal, then so obviously the 0 will be considered as a 0, 1, 2, 3, 4, 5, 6, 7. Okay, because in the octal numbering system 8 is not there, right? You can't use 8 as a symbol or 9 as a symbol. So obviously all 8 symbols are completed, right? And when all the symbols are completed, what we need to do is we need to switch over to a 2-digit number. So then you need to write something like this: 10, 11, 12, 13, 14, 15, 16, 17. You can't write 18 because in the 18 1 and 8 is there. 8 is not a valid symbol for octal, right? And for that obviously after 17 you need to go ahead with a 20, 21, 22 and so on, right? The same way we can write the binary. So binary will have a 2 symbol because the base is 2. So we are starting with a single digit number, so we will write 0 and 1. Then all the symbols are completed because binary will have only 2 symbols, right? And all the symbols we have used. So now we need to switch over to a 2-digit numbers, right? So we will write we can say 10 and 11. Now again all the symbols are completed, so now we need to switch over to the 3-digit number like 100, 101, 110 and 111, right? And so on. Okay. Now suppose if the reverse thing is there, right? Suppose if anybody has given a number, right, like 46, but here you can see the base is 8, means the 46 is given in the octal number. Make sure whenever the octal number will be given to you, 8 and 9 will not be there, right? So here the base 8, that means it is denoting that 46 is nothing but it's a octal number. Now suppose if we want to convert it into the decimal, right? In the previous example what we have done is we have taken a decimal number and we have converted it into the octal number. But now here in this particular example you have a octal number and you are converting it into the decimal number, right? So here fill in the blanks is there and 10 is given, means you just need to convert this number into the decimal form. Okay, so how can we do this? So same, I think if you recall, how we have converted a binary number into a decimal number, right. So, here the number is a 46. So, you just write it down a 4 and 6 here, okay. Then you just need to start in a reverse order, right. First you mention 8 raised to 0, then 8 raised to 1. Suppose if the third digit is there, then you need to multiply that digit with 8 raised to 2, okay. Now, here any number having a 0 exponent, right, 0 power, right. So, that we are representing as a 1, okay. Similarly, 8 raised to 1, it is 8, okay, fine. So, now you can see here 4 into 8, it will make 32. So, I have returned 32 here. 6 into 1, that will make a 6. So, 6 is returned here. 32 plus 6, it will be 38, okay. So, 38 is the decimal number of 46 octal number, right. So, suppose if we are converting 46 as an octal number into the decimal, then we need to write 38, okay. Similarly, here another example is there, the number given that is in the octal format, and you need to convert it into the decimal form, okay. The number given is what? Is a 23, right. So, here 2 and 3, these are the digits that you write it down in this way, fine. Then from the last digit you start, 3 multiply by 8 raised to 0, this 2 will be multiplied with 8 raised to 1, okay. Now, 8 raised to 1 is what? 8, 8 raised to 0, so 1, right. 2 into 8 is 16, so here we have returned 16, 3 into 1 is 3, so we are just writing 3 here, 16 plus 3, that will make 19. So, 19 is the decimal form of 23 octal, clear, fine. Similarly, you can see the another octal number is given, right, for your practice purpose, 66, and you need to convert it into the decimal form. You can understand here 66. So, 2 digit number is given. So, 6 and 6, these are the first and second digit, right. We are multiplying with 8 raised to 0 and 8 raised to 1, okay. Now, 8 raised to 1 is 8, 8 raised to 0 is 1, 6 8 is a 48. So, we have mentioned 48 here, 6 into 1, it is 6. So, 6 is here, right. 48 plus 6, obviously it will make 54, right. So, 54 is what? It is the decimal number. Suppose here 3 digit number 255 is given to you, okay, and we need to convert this particular number, octal number, into the decimal form. So, here 3 digit number is there. So, first of all you just write it down all the digits, let first digit is 2, then second digit is 5, and third digit is again 5, right. So, 255, fine. Now, you just start from the last digit. So, here the last digit has to be multiplied with 8 raised to 0, second last digit that we need to multiply with 8 raised to 1, and the third last last digit, first digit, that has to be multiplied with 8 square, right. 8 to the power 2, that is 64, okay. 8 to the power 1 is 8, and 8 to the power 0 is 1, right. So, now you just need to compute this thing, 2 into 64, it will make 128, right. Similarly, 8 5s are 40. So, here we have mentioned 40, and 5 into 1, that is 5. Now, if you are doing addition of 128 plus 40 plus 5, you will get 173. So, here you can say that 255 octal, right, is equal to 173 decimal number, fine. Okay. Now, see, suppose if a octal number is given to you and you need to convert it into the binary, right. So, how we will convert it into the binary? So, make sure you just need to memorize this particular table, right. Here you know in the octal how many symbols we have? We have 8 symbols, right, and those symbols are what? 0, then 1, 2, 3, 4, 5, 6 and 7. Here I have returned a binary. So, suppose if the octal number 0 is there, you need to write 0 0 0. See, here we will use 3 bits, right, 3 binary bits. Why we are using 3 bits only? Why we are not using 4 bits? Because you know how many symbols you have in the octal numbering system? 8, okay. And how can we make 8? by using 2 to some power, right? Why 2? That is because of we are considering a binary. Okay, this is octal number system. So we know that if we'll do 2 to the power 3, 2 raised to 3, it will make 8. What it mean? To represent any octal digit, you need 3 bits. Okay, and this is very important. So here you can see a 0 will be represented as a 0 0 0, 1 will be represented as a 0 0 1, 2 will be represented as a 0 1 0, 3 will be represented as a 0 1 1, 4 will be represented as a 1 0 0, 5 will be represented as a 1 0 1, 6 will be represented as a 1 1 0, and 7 will be represented as a 1 1 1 1 1. Okay, fine. Now this table you need to use, and see, it's quite simple to memorize. Let's suppose if you have to find a binary, first of all you should know, let's suppose if any octal number is given to you, we need to use 3 bits of binary, right? Suppose if 6 is there, okay, so how we can make 6? Fine. So here you just make 3 bits. Okay, now here you consider 1, here you consider 2, and here you consider 4. Okay, so that's 2 raised to 0, 2 raised to 1, 2 raised to 2. So every time, for every beat, you just have to write a double number, right? Now what we have to do is we need to make a binary of 6. Okay, so here what we will do is 6, that means we need to collect this 4, right? So 4 we have collected. Now suppose 4 is collected, so you just subtract 4 from 6. So now how many things, remains? 2. Okay, fine. So 2 is remain. Now will we shall we take this 2? Yes. If I am taking this 2, right, then 2 minus 2, the number becomes a 0, right? If the number becomes a 0, we don't want this 1. Okay, so I am writing 0 here. So see here, 4 plus 2, right? So that is 6, and we got this. Okay, suppose if you want to make a binary of 7, right? So in that case, what you need to do is 7 is there. First of all, we know that this is an octal number, and we need to convert it into the binary form. We know that there are 3 bits has been used, right? So here I am just making 3 bits. Okay, now this will represent what? The first bit will represent 4, the second bit will represent 2, and the third bit will represent what? 1. Okay, now what you have is you have 7. 7 is more than 4. Okay, fine. So you just consider it. So you write 1 here. So 4 is taken, right? So 7 minus 4, that will makes what? 3. Now you just have to consider, now we have a 3 number, number 3 is given, right? So if the number 3 is there, so will you consider this 2? Yes, 2 is a smaller than 3, right? So we will definitely consider this thing, right? So now 2 you have considered. So 3 minus 2. So now you have 1 only, right? If you have 1 only, will you consider this 1? Yes, obviously we need to consider, because 1 is still remain. So you just write it down 1 1 1, and that will make what? It is a binary of 7. Okay, so it's quite simple, right? Now how can we convert the number into a binary, right? Octal number into the binary. So for example, let's suppose here 46 is given. What is 46? It is a octal number, right? And you need to convert it into the binary form. So the number is actually made by a 2 digit, right? So the first digit is 4. So you just see what is the binary of 4. It is a 100, right? So 100 is there. So here I have mentioned 100. Okay, which is the another digit? It is 6. Okay, so what is the binary of 6? It is 110. So here what you have is you have 110. So you just mention that 110 here, right? And your binary is completed, right? It's quite simple. If you have the table, if you have the proper knowledge of the table, right? If you know the binary of 0 to 7, you can easily convert any number into, you know, the binary. Fine. Here, you know, 23, that octal number is given, and you need to convert it into what? A binary, right? So first the number is made by a 2 digit, 2 and 3. You write down the binary of 2 and write down the binary of 3. Okay. So that is your binary. But make sure when we are writing a number, 0 at the left hand side doesn't make any sense, right? Let's suppose in our daily life, suppose if somebody has given this thing 0005, right, 0005, okay. So what is the value of this number? Obviously 5, okay. We are not considering the 0 at the left hand side. So here this 0 which is there at the left hand side, that you just need to skip it, right? You have to omit it, and finally 10011 is the binary. Similarly, you know, 66 octal number is given, so you just see what is the binary of 6, that is 110. So here you need to write 110 110, and see there is no 0 is there at the left hand side, so you just need to write 110 110 binary. Similarly, suppose this number is given to you 255. So here we have returned the binary of 2, here we have returned the binary of 5. Finally, we just need to check here at the left hand side we have 10, so you just keep this 10, you just remove this 10, and finally what you have is you have 101101, right? So that is the binary of 255. Similarly, let's suppose if a binary number is given to you and you need to convert it into the octal, what you need to do is you just have to make a pair of 3 bits, right? Okay. So here suppose this number is given, what you do is you just make a pair of 3 bits like this, and then you just check it out. 100 100 is what? It's a binary of 4. 110, so it is a binary of 6, you just write it down, and 46 is the decimal number. Suppose here, you know, if we'll make a pair, make sure when you are making a pair of 3 bits, you just have to start from the right hand side and you need to go towards a left hand side, right? So first I will make a pair, that is a 011, and then here what I am having is we have only 10, right? This is a 2 digit, so what we will do is we will insert 10 here, okay. So if it is needed, you just need to insert the 0. Now 010, it is a binary of 2, and 011, it is the binary of 3, right? Similarly, here you can make a pair, it is 110 and 110. So 110 is 6, so 66, that is the octal number, fine. Similarly, here you just need to make a pair, let 101 101, and then 10 is there, so you just append a 10 here, right? So that is what it is, the binary of, sorry, the octal number is 255, right? It is the octal number of this particular binary. So in this particular session, what we have done is we have learned how what is actually octal number, how can we convert a octal number from decimal, right? How can we convert a decimal number to octal number, right? How to convert octal number into the binary number, as well as how to convert a binary number into the octal number. Fine. There is one more numbering system is there, which is called hexadecimal number system. We will discuss more on hexadecimal number system and how the hexadecimal number system will be converted into decimal or into the binary or into the octal number, right, in the next video. Till then, take care and bye bye.